right, so the next one, x log x, okay, as x goes to 0. So this one here, when I plug in, I'm going to get 0 times negative infinity. Okay, so this is a 0 times negative infinity type. I need to put one of those in the denominator to make it either 0 over 0 or infinity over infinity. It's much easier to rearrange this by putting the x in the denominator, and we get this. So now we have negative infinity. Oops, I can't just put x in the denominator like that, can I? And I've got to put it as 1 over x in the denominator. So now I have negative infinity, and as we approach 0 from the positive side, we get positive infinity in the denominator. Okay, so this is our condition. We can apply L'Hopital's here. So I end up with limit as x goes to 0 from the positive side, 1 over x. We've actually seen this same limit before. Over x squared. Okay, so then this simplifies to limit as x goes to 0 from the positive side, and that becomes negative x, which is equal to 0. So as I approach x log x as it approaches 0 from the positive side, we're going to approach 0. Okay, and again, if you graph this function looks something like that. Okay, and there it is. It goes and it's going to approach 0 from that positive side. All right, next one here. This is an exponent, so we need to bring that exponent down. So I'm going to put it into log form. So log y is equal to 1 over x log e to the x plus x. Okay, so this then I can put into a ratio form. As x goes to 0, this will end up being 1 plus 0, so log 1 is 0, and 0 in the denominator. So that's what we wanted. Okay, so that's what I'm going to do. I'm going to put it into the log form. So log y is equal to, I'm going to make sure I put it into a formal limit here. X goes to 0 from the positive side, and we're going to end up with log e to the x plus x over x. Okay, our 0 over 0 condition is satisfied. Apply L'Hopital's. So this is equal to limit x goes to 0 from the positive side, 1 over e to the x plus x. Apply the chain rule. This is going to be the derivative of e to the x is e to the x plus the derivative of x is 1. That's my numerator. My denominator is 1. I can plug into this one here. I'm going to get 1 plus 1 in the numerator. So 2 over 1 plus 0, which is 1. And that's all over 1 itself, which works out to be 2. So we know that log y equals 2. That means that y equals e squared. Okay. So if I were to graph this, the graph of this, if I'm not mistaken, I think the graph looks like this. It's going to be some graph. There's e squared on the y-axis, okay, and it passes through the y-axis like this, and it happens to have an asymptote there. Okay, I better get rid of that. Make sure that's more clear. That's e squared. Okay, there it is. There's our hole on the y-axis. I think this is the last one here. So this one is the limit as x goes to 0 from the positive side. When I work this out, it's going to be infinity minus infinity. Okay, so this we need to put into a ratio form. When we have this subtraction, we want to put this into a common denominator ratio. So we end up with square root x minus x in the numerator, and we end up with x root x in the denominator. And I'm going to rewrite that as x to the power 3 over 2 because it'll be much easier to differentiate. So I'm going to end up with 0 on top, 0 on bottom. There is my condition for L'Hopital's rule. 0 on top, 0 on bottom. I'm getting used to this new pen that I have, so that's why it's getting a little bit blotchy on me. Okay, so I can apply L'Hopital's because I have the condition. So limit as x goes to 0 from the positive side, I'm going to get up with 1 over 2 root x minus 1 in the numerator. This becomes 3 over 2 x to the 1/2. Okay, so x times square root x is x to the power 3 over 2. There's my derivative. Okay, if I plug in here, I'm going to end up with 1 over 0 from the positive side, so it's going to be infinity minus 1, and that's going to be all over 0. Okay, is this an indeterminate form? Well, is it? No, it's not. Okay, the indeterminate form has to be infinity over infinity or 0 over 0. This is not an indeterminate form. Infinity divided by 0 is infinity, right? How many zeros fit into infinity? Well, infinity. That is my limit. Okay, this is my answer here. Okay, so if I graph this, you can confirm that this is actually the case. If I graph this, it ends up being a graph that kind of looks like this and kind of follows an asymptote down there. Okay, so it goes off to infinity when I get closer to 0 from the positive side. Okay, so that is it for today, and I will put out something another day. Thanks.